Good evening, Lokesh.
Good evening, sir.
Evening, how are you?
Fine, sir.
Right. Right. Let's wait for a one or 2 minutes. Hello, Sharon.
Hello, sir.
Yeah, good evening. Okay, let's start now. So we were in the work energy power, right? And in work energy power, we have discussed the questions on the energy conservation. That was the last question we have discussed, right? So to apply the energy conservation, what is the condition needed? So the first condition needed for applying the work energy theorem is what? Energy conservation is what? That only the conservative force should be doing the work. Non-conservative forces should not work. Okay, now if conservative and non-conservative both forces are doing the work, so in that case we should apply the work energy theorem. Energy theorem applicable everywhere, right? Irrespective of the nature of the force. But energy conservation, it's a special case of what? It is a special case of the work energy theorem. We have discussed in the last class. Okay, na? Okay, let me just share the screen. Okay, so let's continue with the uh, power part now. Okay, the next part of this chapter we have is about calculation of the power. Okay, so what does it mean by power? So we know whenever we are applying a force and doing the work, then what will happen? That work, it will take some time to do the work, isn't it? So the power is what? It is the work done, right? Divided by the time taken to do that work. Okay, what is the power? Power is the work done and divided by how much time the person has taken to do that work. That is called as the power of a force. Okay, so let's continue with the power part now. Okay, should we continue now about the power part?
Yes, sir.
Please tell me. Okay, so let's continue with the power. So power means what? Power means work done. Okay, work done per unit time interval. Per unit time interval is called the power. Okay, That means if we want to write it the average power, okay, we can define the power in the two way. Let's call it the average power. The average power means what? How much work has been done divided by what? Divided by the time interval. Whenever we talk about something average, then time interval is relatively large. Okay, so if something happened in a big time interval, in a large time interval, then we define that thing for the average. Okay, so average power is what? Work done divided by the time interval. Okay, so you can write it work done divided by delta t. So this will be called as what? The average power. Okay, and the difference between the average and instantaneous power, what is that? So instantaneous power means what? If the interval, okay, if the interval is small, then what will happen? Then that is called as the uh, in that small interval of time, whatever the work we have done, that is called the instantaneous power. So here we can write it a small time interval dt is there, and in the small time interval dt, dw amount of work has been done. So the instantaneous power we can write it as what? dw by dt. There is one more way you can write the power, okay? That is what? Let's say instantaneous power. A small amount of work done, can it be written as F into ds? Can we write it? A small amount of work done will be how much? F dot ds will be there divided by dt. If you see it here, F dot, what is ds by dt? ds is the small displacement of the particle and dt is the small time interval. So can we say that this ds by dt is nothing but the velocity of the particle? So that's why instantaneous power, if you want to calculate, what will happen? You can use it the dot product of force and velocity. So if you want, you can also write it magnitude of F, magnitude of V, and what? And the cos theta, where theta is the angle between the force and the velocity. So that's why in a circular motion, what happened? If it is a force which is acting exactly along the radius and displacement is happening along the tangent, then what will happen? The force and displacement will become perpendicular to each other, and in that case, the power will become what? Zero. Understood? Please tell me first, do you understand about what is the meaning of the power? Average power, instantaneous power. Instantaneous power, we can write it by two way. One is the work done by time taken or a small amount of work done by time taken. And the second one is what? Instantaneous power can be also written as what? With the help of dot product of force and velocity. Okay, so let's discuss some example on this power calculation. What will be unit of power? Unit of power, what is that? What is going to be its SI unit? It is going to be joule per second. Joule is the energy, second is the time, and joule per second is also called as the watt. Okay, and there is another unit of power, horsepower, right? One horsepower is how much? One horsepower is 746 watt. So horsepower is also a common unit, HP, that is equal to what? 746 watt, we can say that. Okay, so these two are very common units, watt and horsepower. One horsepower is equal to what? 746 watt. Okay, let's take an example and try to find out. A motor pump is there. Okay, in the household you must have seen it. A motor pump is lifting 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 let's say 100 liter of water, 100 liter of water in a minute From ground to fourth floor. Fourth floor means what? What is the height of the fourth floor? So let's say the height of fourth floor is 40 meter above the ground. Okay. And the water is lifted from where? From the ground itself. Okay. Keep in mind the water is lifted from where? From the ground itself. Okay. Above the ground. Find the power of the pump required. Find the power of pump required. Whenever you are using a pump in your house, not every pump will be able to lift the water, isn't it? You have seen it. If you have to lift the water to higher and higher floor, you must use a higher capacity pump, isn't it? Higher power pump. So that's why here what we want, and it also depends on how quickly you want to fill the tank, isn't it? So these are the two factors on which the requirement of pump will be calculated, isn't it? Means what? At what height we want to lift the water and how quickly we want to fill the water tanks. Okay. So try this question and tell me what is the answer coming. How do we calculate it? So here what it will be doing? Tell me, how do we calculate the power of the pump required here? So here pump will be doing the work, isn't it? Can we say that? Here the pump is doing the work in lifting the water. And if pump is doing the work, then if they ask it in the question, what is the work required by the pump? We will calculate the work. But question didn't ask what is the work done by the pump. Question asked what? What is the power of the pump required? So to calculate the power, we need work done by time interval, isn't it? So please tell me how much is that coming to us as your answer? Please calculate it now. Can you first calculate it? What is the work needed? Because once you calculate the work needed, you just need to divide it by time. Okay, na? So please tell me what is the work needed? Please tell me, are you getting the answer?
Yes, sir. 1 minute.
Yeah, just calculate it and tell me what is the answer coming.
Sir, we should consider 1 liter as 1 kg.
Yes, it is water, na? So in case of water, 1 liter will be equal to 1 kg.
Okay, sir.
Because when you will calculate the mass of water, how do you calculate the mass of water? You will write it density into volume, isn't it? And density of water is 1000 kg per meter cube. And I want to calculate mass of 1 liter. 1 liter is 10 to the power minus 3 meter cube. Okay. So if you see the meter cube will get cancelled out, 1000 and that also get cancelled out. So 1 liter of
Sir,
water
six
is
six six point
equal
six
to,
six.
okay. So what you have done here, simple thing is what? That
mgh by time.
we are
That's it.
lifting the water. So it means if I want to calculate the power here, actually here we will calculate the average power. Okay. So actually how much mass we are lifting? So 100 liter means 100 kg mass we are lifting. So M. And when we are lifting that, that means we must be doing some work against the gravity, isn't it? Means
Yes,
we
sir.
are doing, that means the pump is doing, isn't it? So pump will be doing how much work? So M into G into height. What height? 40 meter. So actually this is the work done by the pump, and this work done happened in how much time? So we want to lift this much water in a minute. In 1 minute means 60 second, because numerator it is joule, denominator it is second, then only the unit will come as the watt, right? So that is what we have the power. Now we can calculate it. This zero will get cancelled out. 2 into 3, that is 20. So we have a 2000, है ना? 2000 by 3 watt we are getting, or 666.6, you can write it. That is what coming.
Yes, sir.
Clear? So this is what they ask in the question. Clear? Now the next one.
Yes.
Let's discuss the next example. In this example, what happened? The question gave R is what? R is the position of the particle. Okay. Question gave the position of a particle is given to us, that t cube I cap plus 3 t square plus 4t j cap. Okay. The position of particle as a function of time in the form of I cap and j cap is given. T is the time here in the question. Okay. T is what? The time. And the mass of the particle is given as mass of particle, which is following this position, is given as 2 kg. So they are asking in the question, find the first thing, instantaneous power. Find the first thing, instantaneous power acting on the particle. Okay, means this particle must be experiencing some force. So that force is developing how much power? That is what they ask in the question. Okay, this force having how much power on the particle? Let's calculate it. Okay, understand the question? Chaliye, please calculate it now. A question gave the position of the particle, right? And they are asking the power. So please think about it and tell me what we should do it in the question.
Sir, we can find the force by differentiating the position to time.
Yes. Actually, to calculate the instantaneous power here, we need the force, we need the velocity, right? And the
Yes, sir.
position of the particle is given. So first differentiation will give me the velocity. Second
Second
differentiation,
differentiation.
acceleration, which we will multiply by the mass. That makes it force.
Yes,
And
sir.
then we will take the dot product.
Yes, sir. F dot E.
Yeah. So please try it and tell me how much is that coming. Okay. So first thing we should differentiate this position vector. That gives us the velocity. The TQ differentiation will come 3t squared I cap plus 3t square plus 4t differentiation will come 6t plus 4 j cap. So that is the velocity. We will need that later, okay, to calculate the power. Next, one more time differentiate it. Acceleration will come. So 3t square differentiation,
Sir,
60
36
I
t
cap.
cube plus 72 t plus 40.
Right. So this is the acceleration. We got it. Now with the help of acceleration, we will get the force. Force means just we need to multiply by the mass. Mass is 2 kg given to us in the question. So 2 into 60. So 12 t I cap. 2 into 6. 12 j cap. Now we have both the thing we need for power calculation. That means we have the force and we have the velocity. Let's take the dot product. But here what I'm going to calculate, we are going to calculate the instantaneous power. Okay, so F dot V, we will do it. Let's take the dot product, 12t, 3t square. So 36 t cube will come plus 6t plus 4 and 12. So 12 into 60, 72t, 12 into 4, 48. Right, you can just write it. 36t cube plus 72t plus 48 unit will come as the what? Because we have kept everything in the SI unit. Okay. So this is about the instantaneous powers. So sometimes the position vector will be given to us, right? And then they will ask you the power calculation. So just differentiate it two times. First differentiation gives you the velocity, second differentiation acceleration. From acceleration, you will get the force. Okay, clear? Let's
Yes, sir.
just the next part. In this example, what is given to us? A particle is doing the circular motion. Okay. A particle is doing what? The particle is doing the circular motion here, and the velocity of particle in the circular motion is given to us as you can take it some constant k is a constant, k r t square given, k r t is given. Let's take it as the okay, k r t is given. Chalo, let's take that one, where k is a constant, r is the radius, and t is the time. This is the tangential velocity of the particle given to us. In this question also they are asking what is the power. Okay, and not only the power, in this question they are also asking in the question, find first thing net acceleration of the particle. Net acceleration of the particle, find it. Okay, mass, take it as the m, because if I will ask you the power, then I have to give you the mass also. The first thing, find it, what is the net acceleration of the particle. Second thing, angle made by angle made by net acceleration with tangent to the circle. With tangent to the circle. Net acceleration is making how much angle with the tangent of the circle. And third thing about this topic, power also find it, or instantaneous power. Okay, which power? Instantaneous power I am asking. Okay, to find out these three things, can you tell me this is a uniform circular motion or non-uniform circular motion? Please tell me, is it a uniform or non-uniform? What kind of circular motion is this one? Can you tell me what kind of circular motion is this one? Uniform or non-uniform? Uniform circular motion means what? Velocity will always change in a circular motion. But if it is a uniform circular motion, speed will never change, right? But if it is a non-uniform circular motion, speed will keep on changing. That means the magnitude of velocity will keep on changing. As you look at the expression, you will find out that this speed of the particle is changing with time. So actually, this is what a non-uniform circular motion. If it would have been a uniform circular motion, then the power answer will come zero only, right? In a uniform circular motion, the power is always zero. Why? Because if it is a uniform circular motion, then the only force acting on the particle is going to be radial force, or you can call it centripetal force. Displacement is going to be tangential. So, in a uniform circular motion, the power is always going to be what? Zero. But as it is a non-uniform circular motion question, so here the power is going to be in the calculation. Okay. So please calculate all the things in the question which has been asked. So please tell me how much is that coming? Calculating. Karan and Lokesh, tell me, calculating both of you? Please tell me, calculating or not? See, they are asking in the question, what is the net acceleration? Okay. So in a circular motion, there are chance of two acceleration for the particle. Okay. Tangential and centripetal. If it is uniform circular motion, only centripetal will come. If it is a non-uniform circular motion, which is the case here, it's a what kind of circular motion? It's a non-uniform circular motion. Because if you look at the particle velocity, what is happening? It's a changing. Even the magnitude is changing with time, not only direction. So that's why it is a non-uniform circular motion. So here we will have both kind of acceleration. Let's calculate both of them. So tangential acceleration will come what? It will come dv by dt. Differentiate it. D by dt of k r t. So it will come k r. These are the constants given in the question. So k r and t differentiation one it will come. So tangential acceleration this particle is having is kr. Now we'll calculate the centripetal acceleration. Centripetal acceleration is v square by r. So v square by r. So what are we getting? K square r t square. So actually these are the two type of acceleration the particle is having. Okay. Now if you want to draw it in the diagram, this is how you will draw it. This is along the tangent. This is a tangential. This is along the radial or towards the center. Centripetal acceleration is also called as the radial acceleration or normal acceleration. Okay, na? Because it acts towards the center along the radial line. So centripetal and tangential, both the acceleration we have drawn. Now we will find the resultant. So this is going to be this vector is representing the net acceleration. So if the question they are asking what is the net acceleration, the net acceleration of a particle doing circular motion is what? A tangential square plus a centripetal square. Okay, let's put the value. Tangential we have kr square. Centripetal we have k square r t square whole square thing. Okay, if you take it common, so k square r square. K square r square. You can take it common, so k into r will come outside. 1 plus It is k to the power 4 and k square taken common. So k square will be still there. R square, okay, it's already outside. T to the power 4. So actually, this is the net acceleration of the particle. Understood? This is the net acceleration of the particle, which is the resultant of tangential and centripetal acceleration. So this is the first part of the question. What is the net acceleration? Second part, angle made by net acceleration with tangent to the circle. With tangent to the circle means what? Am I asking you what is this angle theta? अब look at how do I calculate this angle theta? If you look at the diagram, can you say that this theta calculation will be done by tan theta equal to a centripetal by a tangential? Just check it. Because I am calculating the angle with the tangential line. So that's why I am writing AC by AT. Clear? Now AC value is how much? K square RT square. And AT value is what? K into R. K get cancelled, R get cancelled. We have KT square. So even though this angle also will keep on changing as the time progress. Okay, na? Because net acceleration is dependent on time, isn't it? So the net acceleration value will keep on changing, and net acceleration angle made by the man made with the tangent also will keep on changing. Now the last thing, if I ask you what is the power, can you tell me which acceleration will contribute for power, or rather say that which force will contribute for the power, tangential or centripetal? Please tell me. Can I say that this tangential acceleration gives me a tangential force and that is going to give us the power? Why? Because the centripetal acceleration gives me centripetal force and that force is perpendicular to velocity. And the moment a force becomes perpendicular to velocity, what will happen? The power of that force will become zero. So that's why if you want to calculate the power here in the question, what you should do? Mass into tangential acceleration, that becomes the tangential force, into the velocity of the particle. So please tell me, understood up to this what we have discussed? So
Yes,
now
sir.
just put the value. So mass, tangential acceleration is k into r, and what is the velocity? The velocity is again krt. So we have m k square r square and t. So this is the power created by the force which is when you calculate the power during the circular motion, only calculate the power of which force? The power of tangential force, not the centripetal force. The reason is what? That centripetal force is going to be perpendicular to the velocity. And if a force become perpendicular to velocity, then that force power will become zero. So the power will only come for the force which is along the velocity. Clear? Sometimes the force is not exactly along, not exactly perpendicular. So in that situation, you have to take component of force along the velocity and perpendicular to velocity, you have to take the component and calculate the power of which component? The component which comes along the velocity. Okay. So these are the some of the examples of power calculation. Okay. Now we have is the momentum conservation of linear momentum. Okay. But before that, we are going to discuss about the center of mass. Okay. You remember in NLM I said that we will discuss about the center of mass of the particle and the Okay, so let's continue with what? The center of mass part. Okay, should we continue now? Center of mass part. That topic is still there. We should discuss that one also. Okay, please tell me clear. Please tell me clear up, everyone.
Yes, sir.
Right. So let's discuss about the center of mass. Now, in the center of mass, we have to calculate the center of mass of two type of bodies. One is what? One is the particle system, and second one is the distributed body. Particle system means what? Many particles are there, and we want to locate the center of mass of the combination of those particles. Okay, that is called the center of mass of combination of the particle. And the second is what? Like rod is there, where the center of mass of rod will come. Next, a ring is there, or a semicircular ring is there, semicircular disc is there. Okay, so where the center of mass of this body will come. Okay, so that is called center of mass of a particle system and center of mass of continuous body. Now, first of all, what does it mean by center of mass? The center of mass is what? It is a convenient way to represent where the total mass of the body can be assumed to be present. Please keep in mind, what does it mean by center of mass? Center of mass means it's a point. It's a point in the space where we are assuming that can I replace the total mass of the body to be passing through that point? It's just a point, right? Which helps us doing the calculation easily. It doesn't mean that center of mass is a point where all the mass is actually present. Understand the difference between the 2 points? Actually present, and it's just a hypothetical point. Understood? The center of mass means what? This point can be inside the body, this point can be outside the body. Okay, na? It is just a point. Understood? What is the center of mass? It is a point point inside or outside the body. Inside or outside a body where all the mass of a system, if it is a body, for the body, sometimes it is a combination of body. Okay, so it is a point inside or outside a body where all the mass of a system, see that. Now the important word, can be assumed to be concentrated. Assumed to be concentrated. It doesn't mean that this is the point where all the mass of the body lying. Mass of the body is distributed throughout of it. But instead of drawing the mg from every point, we can draw the mg from where? It's a center of mass. It gives us the same effect to us. Okay. So now if I want to calculate, there are two cases of center of mass calculation. Okay. The first one is what? Center of mass of discrete particle system. Okay, discrete particle means what? A number of point masses are there. Okay, discrete particle system means what? A large number of particles are there and they are arranged, and we want to calculate the center of mass of that arrangement. Okay, so let's say this is something x-axis and y-axis we have. Let's say the particle m1 is located at this point. So this particle must have a position vector, isn't it? There is another particle, let's call it m2. Its position vector is something r2. There is a third particle here, M3. Its position vector is R3. One more particle is there, M4 is there. Its a position vector is something R4. Like that, many particles are there, okay? So if we want to calculate RCM means what? The position vector of center of mass. RCM means what? The position vector of what? The center of mass. Okay. So if you want to calculate the position vector of center of mass, then we can write it M1 R1 vector plus M2 R2 vector plus M3 R3 vector. Like that, as many particles are there, all we should write it divided by M1 plus M2 plus M3 plus M4, like that. Look at the denominator, you will find something interesting. Is the denominator is nothing but the total mass of the system? Mass is a scalar quantity. When you are adding M1, M2, M3, M4 like that, so that means actually what you are writing in the denominator. You are writing the total mass of the body actually. Okay. So that's why you can also write it RCM as, can you write it like this in the summation form? MIRI divided by what? Summation of MI. Okay. Divided by what? Summation of MI, you can write it. Or you can also write it like this, the RCM or position vector of center of mass, you can write it as summation of MIRI divided by what? The total mass of the system as well, you can write it. So this is the center of mass of what? The discrete particle system. Sometime what you have to do, you can directly calculate the position vector of center of mass. Sometime instead of directly calculating the position vector of center of mass, we can also calculate x coordinate center of mass separately, y coordinate separately, z coordinate separately, and then what we can do it, the x coordinate we will write it with I cap, y coordinate with j cap, z coordinate with k cap. So this is just the simplified form I am going to write it. Can I write it? If I want to calculate x coordinate of center of mass, I should use it m1 x1 plus m2 x2 plus m3 x3 divided by what? m1 plus m2 plus m3, like that. If you want to calculate YCM, what you will do it? M1 Y1. But please keep in mind that whenever you are writing Y1, Y2, Y3, these coordinates, don't forget about the sign of the coordinate. Don't forget the sign of the coordinate. So M1 plus M2 plus M3, like that. Same way you can write it for the z coordinate also. So this is the center of mass of what? This is the center of mass of discrete particle system. Means if a number of particles are there, okay? If a number of point masses are there, then this is how we will calculate the center of mass. Okay. Now the next part will be what? If a body is there, then how do we calculate the center of mass? So instead of doing the summation and integration is same thing. The difference is what? In the summation, the particles are distinguished one, separate one, which can be counted. And integration, when we are doing the integration, then we are doing the same thing, adding only, but the particles cannot be counted. Infinite number of particles are there. So then what we will do it? We will replace it by the integration. Okay. So let me just write it, the center of mass of this continuous body also, and then together we will discuss some questions. Some standard bodies are there, so for that we will remember, then we will have the combination of body which we will calculate. Okay, the center of mass of continuous body means what? Like a rod is there or a ring is there, right? So these will be called as the continuous body. Okay. So for that, what I can write it RCM if I want to write it. So here you see na this expression. Instead of writing integration summation, we will write it DMR. Understand? DMR means what we did. Even a continuous body is broken into infinite number of small bodies, small particles. You can say that. Okay, a continuous body is broken into what? Infinitely small parts of the small bodies, right? And dm is what? Dm is mass of that infinitely small portion, and r is what? R is the center of mass of that small portion, divided by summation of mi, that means summation of dm again. So for particle system we should use the summation thing. For continuous body we should use the integration. Don't worry, we will discuss the questions on both of them. So if I want to write it in the XYZ format, what I will write it? If I want to calculate XCM, what I will do it? Integration of dm into x by integration of dm. Okay. What is x here? X is the x coordinate of the center of mass of the small element of the body. YCM, how much it will come? Integration of dm into y divided by integration of what? Dm. Like that, x, y, z coordinate we can calculate it. Is it clear? Clear? So first let's discuss two example on center of mass calculation of what? The discrete particle system. Okay. Discrete particle system means here I am going to take a number of particles given to us. Okay. Let's take an example. In this example, what happened? A square is given to us. Okay. And let's take this is the x-axis. This side of the square is along the x-axis, and this side is what? Along the y-axis. Now at the this will be what? And this will be the origin for us then. Means this coordinate is going to be 0 comma 0. Let's take the side of the square is a, and this side is also what? A. Now at the four corner of this square I'm going to keep some particle. Here m, here 2m, here 3m, and here what? The 4m has been kept. But all these are the particles. Keep in mind I am taking right now about the particle. Okay. So the question they are asking, find center of mass. Okay, find center of mass of this arrangement of particle. This arrangement of particles means for these particles. Okay, for the arrangement of these particles. Okay, where the center of mass is going to be, means you have to tell me that what is the x coordinate of the center of mass and what is the y coordinate of the center of mass. Okay, so please tell me how much is that coming. Each particle mass is given to us, each particle location is given. That means each particle mass and each particle coordinate is given to us in the question. Now use that and tell me what is the answer coming. So please tell me how much is this coming. Calculating this one. It's a simple calculation. Just think about it and tell me how much is this coming. Tell me, where is the center of mass of this arrangement of particle coming to us? See, if you want to calculate it, you can calculate x and y coordinates separately. ठीक है, but xcm if you are trying to calculate, then what it will come? See, m mass, what is the x coordinate for m mass? So m mass coordinate is 0, comma 0. That means if you are writing the x coordinate, it will come 0. For 2m mass, what is the coordinate will come? A, comma 0. 3m mass, A, comma A. 4m mass, 0, comma A will come, right? So always try to identify the coordinates first, okay? So xcm, when you will write it, what it will come? M mass x co हाँ बंद हो गया बाबू. Okay, x coordinate if you are trying to calculate, so m mass x coordinate is 0 plus 2m mass x coordinate is a. So when you are calculating the x coordinate of center of mass, na, just focus on the x coordinate. Don't worry about the y coordinate. You can always calculate x and y coordinate of the center of mass separately. It doesn't affect each other, okay? Next, 3m mass if you are calculating a, 4m mass 0 divided by m1, m2, m3 and m4, isn't it? So if you calculate it, this is 0 and this is 0, right? 2 plus 3, 5 ma we have, and 4, 3, 7, 2, 9 and 1, 10 m we have. So we got it a by 2. So that means x coordinate of center of mass of this arrangement is a by 2. Now we will do the same thing for the y coordinate. YCM if I am calculating the m mass, what is the y coordinate of m mass? Again 0. 2m mass y coordinate 0. 3m mass y coordinate a. 4m mass y coordinate a divided by. Again, can I write it directly? 10m, m plus 2m plus 3m plus 4m, isn't it? Simplify it. This is 0, this is 0, 3 plus 4. So we got it 7a by 10. We got it. So that is our YCM. Earlier, what we have calculated? We have calculated XCM. So if someone asks you what is the center of mass, right? The center of mass, you can also write it like this: a by 2, comma 7a by 10. Or you can also write it, sir, it will come a by 2 I cap and 7a by 10 j cap will come. So both are the correct way to represent. Then you will write it like this: RCM. Okay, so you want to write it in the vector form, write it in the I cap j cap form. You want to write it in the coordinate form, write it like this. Understood? There is one more question very commonly comes like this one. There are two simple particles are given to us, m. There is another given 2m, and the separation between them is given as d. Can you tell me where will be the center of mass of this arrangement? Will it be near to the heavier mass? With common sense, can we say that? With the logic, can we say that center of mass of a system is always where? Always near to the heavier object. Okay, near to what? Heavier object. So center of mass of this one will come somewhere here. And if you want to calculate that distance, you can also calculate. A simple trick is here, like what is the distance between these two particles? D. Look at the mass ratio. One is m, other one is 2m. So you can just distribute this total distance between them in the ratio of their mass. Matlab 1:2 ratio you have to distribute it. So if you distribute it into 1:2 ratio, this one will come d by 3 and this one will come 2d by 3. So like that. You want to calculate it? Yeah, you can do the calculation also. How we will do the calculation? I will consider this as my origin 0, 0. So this point will become d comma 0. Let me calculate xcm. So m into 0 plus 2m into d divided by m plus 2m, right? We calculated and we got it as 2d by 3. YCM 0 will come because m also 0, 2m also 0. No need to do the calculation, isn't it? So m plus 2m, if you do it, it will come 0. Do you see that? What is the xcm coming? 2d by 3. So 2d by 3 from where? 2d by 3 from the origin you have chosen. Okay. And you have taken origin where? You have taken origin on the particle of mass m itself. So from the particle of mass m, where the center of mass is 2d by 3 distance. So from the other particle, what distance it will come? D by 3 it will come. Or that is one way to calculate mathematically using the equation. And what is the other method? Other method is what? Just divide the distance between these two particles into what ratio? In the ratio of their uh, masses. Okay. So please tell me, clear up to this?
Yes, sir.
Please, right. So let's meet it on the Wednesday now. We'll discuss about the center of mass of continuous body, like the ring is there, rod is there, disk is there, okay? And then we will discuss about the combination of the bodies. Means a plate, a disk kept together where the center of mass will come, right? And after that, we'll go to the conservation of linear momentum thing. Okay? So let's meet it the uh, Wednesday, okay?
Okay, sir.
Right? Okay. Good evening, good night.